Hello, my name is Abhinav, and this is my 310 Homework 2 video. So here's the overview. The first question was asking to use the Master's theorem to solve the given functions and compute and find a, b, and f of n and their values from the given functions. Um, and mention which case the function belongs to, and obviously regularity condition if it's case 3, and finally write the full time complexity of the function. Okay, so let's start with the first one. The first one is 4 t of n divided by 3 plus n cubed. So looking at this, I can A is the one before the recursion function. B is the inside the recursion function itself that's manipulating n. And the plus and the cubed is the f of n. So uh, in case 3, we can clearly tell that oh in case 3, we can clearly tell that f of n is equal to n cubed, which is the same thing as saying we need to find omega of n to the power of log 3 4, log base 3, log 4 of base 3, I don't know how to say that, plus e. um and after solving it, you can find that e has to be uh 3 minus log 3 over 4, and that has to be greater than 0 for e to be valid. mm, so this is case 3, we have to do the regularity check. Um, so that is just a f of n over b. So that's 4 n over 3 cubed, which is the same thing as saying 4 over 27 n cubed, which is less than c n cubed, where c is uh 4 over 27, since it's less than 1, and 4 over 27 is less than 1. So we know that for all large n, it will work. So the time complexity is uh, theta of f of n is theta of n cubed. Okay, problem 2. So the original function was 3 times time complexity of n over 2 plus n times log base 2 n to the power 2. Um, A in our case was 3. Here, B is 2. And f of n is n times log base 2 of n times to the power 2. Sorry. So f of n in case 1 is um uh it's just a big O of n to the log base 2 of 3 minus e, where is in some range of 0 to log 2 over to 3. As this is a bit more than 1, so e is like 1.2 something. Um yeah, so the time complexity for this one is just what's it called? Theta of n to the log 2 over 3. N to the power of log 2 base 2 of 3. And then the third one here, we're looking to find 2 times t of n divided by 4 plus square root of n. So a is 2, b is 4, function is square root of n. Um, it's case 2, so we can figure out that, hey, it's a theta of a half, which is just saying square root of n, but n to the half times log of k plus 1 over n. And we know that k has to be 0 in this case, with k being 0. So actually, the big theta is n to the power of 1 over 2 times log n. And for 4, this is my randomly generated array. So this problem it gives us discrete random integers and then sort this array step by step by using the merge sort algorithm. Um, so how this is done is it is given a big array, in this case 16, but it can be any as big as like you want it. Then it divides the array into multiple parts until it gets to one instance of the array. So if our array is 16, the first step will be to divide it in half, so 8 and 8. Then it will be to divide it in half again, so 4 fours. Then again, so then we'll get 8 twos, and then again, and then we'll get 16 ones. And then we build it back up, combining them back up, and doing the logic of us making sure to put the lowest in the left and biggest in the right. So first thing I wrote the array down. So it's 42, 7, 88, 15, 63, 29, 74, 3, 56, 11, 91, 34, 20, 68, 47, 5. The first thing I cut in half, just dead center. So 42 all the way to 3, and then 56 here all the way to 5. Then I cut those in half, so 42 to 15, and then 63 to 3, 56 to 34, 20 to 5. Then I cut those in half, so 42, 7, 88, 15, etc., etc., etc. here. Then I cut them individuals. And then we started merging them. So since we have these instances, we're not going to combine these instances. So if I have a 42 on one hand and 7 on the other hand, what I'm going to do is I'm going to first check which one is the lowest, and that's going to be my first at index 0, and then the bigger one goes in the second index. So in this case, 742. If we do the rest of them, we get 1588, 2963, 374, 1156, 3491, 2068, 547. Now we need to merge these individual two sizes. So how it's done is we first check the first of each of the arrays. In this case, so this is the first step. These are the two checks. In this case, 7 is biggest. It's smallest, sorry. So we put 7 into the array. Then we check the one that we're currently looking at, which is in this case 15 still, with the next instance in the left one, so 42. That's why I put 2 here, as in saying this is going to also be checked second place. Then these two are checked, and the lowest one goes, which is 15. Then we check the third one, which is moving this pointer here. So this is 3, 3, etc. So that's how, then we put 42 and an 80. So that's how we merged it with size 2. And this is the rest. And this was the same amount of steps as for size 4. It will take, um, so we check the first instance of each, whichever is lowest, we put into the new array, and then we keep going until both of these arrays are empty. Let's say that all of these were lower than this 7, then all of these would go first, and then everything from 7 on would go. And then we have 2 arrays now. And then the last 2 are done with the same exact concept. We first check the first 2, whichever's lower goes into the new array, and then we check the next one, so in this case 7 and 5, and then whichever low is in the new array, then we move the pointer across, keep moving it until we're at the end of both arrays. And then that's when we have our fully first merged um, array, merged and sorted array. I think that's it for this. Great. Thank you.